Good afternoon. Welcome. Hi, I'm David Chaikin with Altascale, and I'll be talking about running Spark and MapReduce and other Hadoop creatures together in production during the next 30 minutes or so. So here's the agenda for the talk. I'm not going to let you go to sleep in your post-lunch mid-afternoon haze quite yet. I'm going to ask you some questions in a minute. But this is what I'm going to talk about. The first thing is why run MapReduce and Spark together in production, and what about other frameworks like H2O and Impala and so forth. And it's important to motivate that because trying to run the batch and interactive jobs leads to a bunch of challenges. I'll talk about those challenges and then get into specific issues and solutions that we see just setting up Spark and Impala and H2O and so forth, and then get into the ongoing challenges of what does it take to keep things running in this kind of dynamic environment with both interactive and batch in the same cluster, and then conclude with a perspective on doing it yourself versus doing Hadoop as a service. Okay, so, what I mean by in production is kind of specialized. By in production, and I'm going to ask you whether you're living the life in a second, I mean that if the cluster goes down or the MapReduce jobs don't run or the Spark jobs don't run, there's a business owner somewhere who will say, David, my sales reports aren't available this morning. What happened? Or, David, the billing for my customers didn't run because something happened to the Spark cluster today. So that, what I mean by in production is the business that you are driving depends on the technology that a lot of us are building and offering to the business. Okay, so here's the quiz. How many of you in this room are running MapReduce or have access to a Hadoop cluster that's running MapReduce? Okay, excellent. And I'll assume that y'all are up to speed on Yarn and Hadoop 2 and so forth. At previous Hadoop summits, I've asked about Hadoop 1 versus Hadoop 2, but I've seen that most folks are on to Hadoop 2 by now. Okay, same question, but how many folks running MapReduce in production? Your business depends on MapReduce. Yeah, almost as many hands, some a little more tentative, not quite up there all the way. Because it's an experience. Okay, how about running Spark? Not quite as many, but it looks like almost half the audience. Okay, Spark in production. Your business depends on Spark right now. Okay, fewer hands. And this is in general what we're seeing. How about Impala, running Impala? Interesting. This being Hadoop Summit, not surprised. We'll get a different answer at Strata probably. And then how about other products like H2O or other dynamic infrastructures for data scientists? And are anybody in production with those? It's interesting. Let me just give you a background on what is Altascale, mostly to tell you what our perspective is on all of this. So we're a bunch of infrastructure nerds. We run Hadoop as a service, which means in our data centers, we rack and stack hardware and build them all the way up from concrete and networking and so forth. And then we sell those Hadoop clusters as a service to other companies. And it's those companies that are running in production. Their businesses depend on the clusters that we provide to them. And it's kind of interesting. The breakdown is very similar. Oh, you know what I should have said? How many of you are on TES, actively running TES jobs? Good. And then TES in production? Almost as many. It's then a serious crowd here because most of the time when I asked if you're running something, you're also running it in production. Your business depends on it. And we see over our customers, we're seeing about the same split. We're seeing MapReduce, of course, is where a lot of the work is happening. TES is starting to come in. It is almost every single one of our new customers that says, hey, how about Spark? Can you get Spark set up? And the answer for months for us has been, yes, we can set up Spark. What version do you need? And get that going. And we actually have, I think, more customers in production with Impala or H2O than we do with Spark, but these systems are coming up together. And it's important to talk about why, I think. So the motivation here is round about 2005 and 2006, when we were really starting to think about the investment case for Hadoop. Hadoop was really, unless you were at Google, Hadoop was the only game in town for data science at scale. But there was a bad trade-off there. You had to find very, very special data scientists who were capable and willing to program in Java and to use kind of the raw MapReduce interfaces. And it was kind of a bend for data scientists to twist their heads coming from R or MATLAB or other systems to the Java world. And so one choice was, okay, the data scientists are going to code in Java. And the other thing that we did in the industry is we trained a bunch of data engineers to work directly with Hadoop so that the data scientists could do statistical analysis, but if they needed to go directly to the data source, a lot of the time they'd go through data engineers who were doing a lot more of the programming and heavy lifting, and then there was friction associated with that. So roll forward a few years, and things are looking better, but they're looking better in certain areas. And to understand that, I just want to go briefly through a conceptual view of a data scientist's workflow and what data scientists do. And this is not intended to be standard or all-encompassing. It's representative, but we are getting some traction as we talk to our customers and other companies about this. So when you think about data science, it's good to think about 3 loops of time frame. So the inner time frame happens in modeling. That's where the data is sitting there in the refined form that data scientists can operate on. So a lot of the times it's a graph or a bunch of matrices, and it's an environment where the data scientists can iterate on their statistical methods. So a lot of the time they're building some sort of model and investigating the features of that model and tuning the coefficients that go in front of the features that are extracting some sort of data some sort of signal from data, which is often very big and very noisy. But that data has to come from somewhere, so typically there's some very noisy source data at the front end of this process. So that source data, as we know, they're web logs, they're transaction records, there's whatever they're coming along Internet of Things, and it tends to be very messy. It can be incomplete. The date stamps are inconsistent, if not wrong. The time zones are inconsistent, if not wrong. Currencies and so forth. So a lot of us are living the life where we need to go through that source data, put it through some sort of production cleansing, and then get it up into typically a fairly structured store. I'm not talking about third normal form and all of the good stuff and ACID and the stuff that we get from relational databases. We kind of gave up on that so that we could extract the signal from here, but it is a fairly structured store, and we're finding it very common for folks to be running a layer like Hive to provide SQL access or something similar to that moderately structured data. And that's probably underneath what a lot of you are doing with MapReduce and now TES. The interesting thing here is that data, that normalized data, isn't great for data science. So the data scientists do what we're starting to call flattening, which means extracting the data and getting it into that graph form or that matrix form or whatever form the data scientists really need to do their quick iteration. So this is pretty structured and pretty normalized. This flattening process actually denormalizes the data and kind of splats it into longer and larger records that are easier to execute on. And then there's this other path here where there's, so the normal production path, by the way, is source data, production cleansing, structured data, denormalization modeling, and then ultimately a handoff to some sort of serving system. That may be a business analytics system like Tableau. It may actually be a web serving system. The initial use case for this was web search out here. There's another path that we think is important that we call exploration, and that's the outer loop of this time frame where data scientists need to go back to the source data and say, you know, we're not taking the browser information, or we're not taking the iPhone version information and putting it through this path, but I think that I can get some lift in my product by getting to that information. So what I need to do is I need to get at it and explore it. So those are the different time frames: modeling, flattening, exploring, with this very important process of production cleansing there. So the good news is there's a whole bunch of tools that are coming along. Spark is certainly the latest hotness, but Impala provides much more interactive SQL queries. H2O is great for R or Python enthusiasts, and a lot of the time they play the same game, which is load as much data up into DRAM as you can, yeah, be smart about it, but load it up into DRAM, and hey, look, when your data's in DRAM, and if it can fit in DRAM, then your queries go a lot faster than they do when you're getting data from disk and back onto disk. So whatever these systems say about, oh, we're not just for memory, what we find is that when people are actually using them, those systems really do want to use a lot of memory. And we also have this meme that, hey, that's it. All you folks who have been working on Hadoop, game over. MapReduce, game over. Everybody onto the new systems. And so there's this meme that's been going around for years, at least in the Hadoop community, that, oh yeah, the folks at Google moved on from MapReduce years and years ago, and y'all are behind, right? It turns out that there's a lot of MapReduce that's still being run at Google when you look in their infrastructure. And you know, for the most part, first of all, it's just not responsible to come out every few years with a rip and replace plan. When we go out, especially to our enterprise customers, what we want to do is say, look, big data is an interesting space. It's interesting because you can derive a competitive advantage by processing that data. We'll get you onto Hadoop, which is open source and at least standard from an ad hoc perspective, and then we'll live the life with you. We'll get you into production, and as these new systems come along, they will be additive. They won't be rip and replace. So all of the experience that you've built up over time, that's still valid. If you don't have a business reason to migrate an application from MapReduce to some other infrastructure, keep on running it. Focus on where you can go next to build value for your company. And so one thing that's really happening in this area of modeling over the last few years is we're getting incredibly productive environments for data scientists, and because they're focused on making the process of either iterative investigation, I'll do a query, look at the results, do another query based on that, look at the results again, or iterative algorithms like being able to traverse a gradient and find a local maximum or local minimum. Those kinds of algorithms really want to run iteratively, and they do great if you can load your data up into DRAM and then process them very quickly rather than off of disk, sort onto disk, off of disk, sort onto disk, right? So it's great to see these environments coming up, and that's really the motivation here. The challenge that I presented up front was data scientists. Some of my favorite data scientists, my favorite data scientists a decade ago were awesome Java programmers, no question about it. Some of them are certainly at this conference. But add to them some of my new favorite data scientists who say, I don't know Java, I don't want to have to know Java. I got trained in MATLAB, I learned R, I learned Python. I'm comfortable in those environments, and I want an environment where I can run algorithms, not write Java code. And that's what's happening in this space right now. The issue here is that there's some challenges, and you know, I'm not saying that it's exactly the same, but it's analogous to this problem that we've always had over the years with online transaction processing, OLTP, and online analytics processing or application processing, OLAP, right? What we found over the years is that it's best to have different environments for these different functions, but the issue is, to go back just one slide, that it's a lot more convenient for data scientists to have all of this in the same environment, especially when it comes to exploration. But even this interacting with the structured data store and redoing the flattening and so forth, it's just critical for the speed of invention and investigation and so forth to have all of these in the same environment. The problem is when you actually do that, you run into issues with customers saying, why is my Spark job, why do my Spark jobs cost so much? Why is it not starting? What's happening to the cluster when I'm running both Spark and MapReduce or TES or running Impala in that same environment? So I went through our support records, I went through our development curve. So first I'll go through our development curve. What did we have to do to get Spark and MapReduce and actually TES and Impala all working in the same cluster? Okay, so the first issue is these systems are memory intensive. That's really what it comes down to. And so the challenge here, first of all, is if you take a stock installation of Hadoop, or kind of the conventional wisdom for how to set up a Hadoop cluster, it's with relatively small, by today's standards, in terms of the container size when it comes to memory and processing. So I'm going to use this graphic in the next few slides, so I'll explain it. This is intended to represent a Hadoop cluster down at the bottom here, with each of these circles representing a node. And then we use a capacity scheduler a lot, so there are 3 different queues represented here, and then within each queue there are jobs. So Q1 has 2 jobs, each of which has 4 tasks. Q2 has 1 job with 6 tasks. Q3 has 1 job with 8 tasks. And the size of these tasks is representative. So these big circles are approximately the size of a node. So each one of these tasks really wants to take over a whole node. And if you've got a relatively homogeneous cluster that's relatively unloaded, yeah, that's easy to schedule. But here's where the challenges come in. Okay, so let's say you've set your container size when it comes to memory to be nice and large, and then you crank up your Spark jobs or H2O, and they're running great. Then along comes a different kind of job, and so this job in Q1 is intended to represent a MapReduce or a TES job with smaller containers. That's why it's little circles, and this is the kind of job that Hive typically starts up. So when we first did that, it was kind of awesome because the interactive jobs got scheduled, and then what Yarn said is, oh great, look how much memory I've got available on the cluster. I'm just going to take over this whole thing. So in order to get these jobs scheduled, I needed to say, yeah, you can take over all the memory on the machine. And Yarn said, great. And it took as many of these containers as these MapReduce tasks, and it packed them into as many nodes as possible, and our nodes in our clusters started exploding. So the solution for this one is right here. You need to size your containers, if you're not yet doing it, in terms of both memory and processing, so that you can get the right balance there. And to do the processing container sizing, these are the Hadoop configurations. Okay, so once you've done that, great, everything's working. But let's say that Hive job was high priority here in Q1, and these jobs here with the larger jobs coming from Spark or H2O or whatever, they're lower priority. So what can happen is Yarn can schedule the tasks for the higher priority job, and then they can keep running through the nodes, and then what can happen is the Spark or H2O or these jobs that require large containers and a lot of memory, they can get starved out because, let's say, this job here with the black tasks, that's only got 5 out of the 6 containers that it needs. And this one here only got 4 of the 8 large containers that it needs. And Spark clusters tend to be all or nothing. I need my nodes, and then I can start processing requests. Same thing with H2O that we've seen. These processes really want to be gang scheduled. So where we're at with this is actually a couple of not great solutions, but then the community is working on some features that will combine into a better solution. So the first solution is, okay, if you can, run your Spark jobs or your H2O jobs or whatever before starting the batch jobs. If the algorithm permits, you can reduce the container size, which will give Yarn a little more room to maneuver. But these two solutions are kind of operational, but they're also kind of hacky. Where the community is going is to implement 2 features. One is node labels, and then I hope the other is gang scheduling. Node labels is moving along through the JIRAs in kind of an interesting kind of way through the community. Gang scheduling is kind of stuck, and we need to watch what the community is doing with respect to solving this kind of class of problems, but we are going to need to work together to make that all happen. Okay, so those are kind of general things that need to be done to get these things working moderately well in production together. And then there's another number of other things to watch out for. So challenge number 1 that I'll bring up is security. So user management isn't uniform over these different platforms. So when you start with MapReduce, when different groups are collaborating on the same cluster, you need to get the users right throughout the cluster. You also need to get the groups right so that the right people can share the right data. Hive then, if you're using Hive Server 2 for your connections into Hive, then you start having to get into configuring proxy users. Right, so then the Spark applications and Spark clusters are kind of interesting because what we see are we've got groups of people at our customers who are using resources, and one of them will start a Spark cluster or H2O or Impala, and these things will set themselves up, and then they'll say, ready to process queries. But then you can never be sure exactly who is the person who's actually running those queries. So it's kind of an interesting area to be getting into from the perspective of some of these new systems coming along. Impala, or at least Impala without Sentry, is kind of interesting from a security perspective. It says, I got to be me. I got to be the Impala user, again, unless you set up Sentry. And that brings in a whole nother kind of can of worms. So you need to be careful about that. And then, as usual, watch out for your cluster administrator accounts. So if you have people who need to be able to get onto the systems and sudo, you need to be very careful to make sure that the people operating at the application level can't figure out devious ways to take over those administrator accounts. Okay, so that's user management. Then there's port and protocol management. And this started out being really fun with Spark, and now it's looking like Spark is maturing. But so most of our customers who are running Spark right now are running one of the older versions. They haven't quite upgraded yet. And for those older versions, the node that's talking to the Spark cluster, it essentially needs pretty much all of its ports open, because out of the box, Spark will just it's got to be free. It's got to use whatever ports in the infrastructure that it wants. I told you, by the way, I warned you, we're infrastructure nerds, so we think about this kind of thing. The best practices for security are you know what application is using which ports, and you audit that, and you make sure that you only have the internet TCP ports open for the applications that you know are actually running there. But you know, it's very typical for kind of a new infrastructure that comes along to say, I don't care about all that stuff, run forward. Spark has improved. If you look at the documentation between these two versions I have on my slide, you can see that at least they're breaking out, okay, what are the different services? They still use whatever port they want by default, but you can lock them down a bit more now. Okay, so the interesting thing that we're seeing with these interactive systems is, hey, I can load up a whole lot of data into DRAM, which means I can serve it interactively. So what I want to do is, that means I want to have a web server, whether it's a Tableau server or some special purpose server that hits that data and serves real-time business analytics for customers. That's really exciting, especially because the customers can do interactive queries, slice and dice on more data than they've ever been done before. But then the question is, okay, where do you run the web server that's serving these business analytics? And really? Oh, don't think about it, just put it on the name node. The thing that's supposed to be the most stable and most secure thing in the whole infrastructure, yet we're starting to see, well, I don't know where to put it, and the name node's there, so let's go for that. No, don't do that. Think carefully about web serving. And like I said, we build our own owned and operated Hadoop clusters. So we're not very fond of doing that particular work on Amazon Web Services. I have to say, we are great fans of AWS for running web serving. So if you're using AltaScale systems and you're interacting with a web server, a lot of the time you're going to be interacting with a node that's sitting on AWS. So you need to think carefully about how security and interactivity and stability and availability relate to one another, and get the web servers that people are going to be hitting from browsers, possibly browsers from all over the internet that may be coming inbound. You need to think carefully about, okay, maybe that belongs in a web serving infrastructure as opposed to on my cluster. Okay, so whether you are running Hadoop internally for internal groups and business units, or you're like us and we're running it for other companies, at some point cost attribution becomes important. How much is each business unit spending in terms of storage and compute resources? And for these new systems, it's getting complicated, because let's say that I set up a Spark cluster and I'm going to use it for one of these web serving applications. So when I set up that Spark cluster, maybe I haven't even loaded the data into the RDDs in DRAM yet. Maybe it's just sitting there reserving resources. Well, how am I going to bill for that? And this is a question that's playing itself out, at least externally, in terms of how we talk to our customers. And you'll probably want to think about that in relationships between business units that are using the same infrastructure. The question here is reserving resources. Just because I've started a Spark cluster and it could, in principle, use a lot of DRAM, do we start charging for those resources then, or do we wait till it actually starts serving queries? And what do we do in the meantime? And in the meantime, yeah, well, maybe we can oversubscribe and we could steal some of those resources back. But then if we do that, in particular for a MapReduce job or some other large job that's not going to relinquish those resources right away, well, that may compromise the availability or the response time of this interactive thing we've set up. So this is very much an open area that we're starting to come to grips with. Okay, so like I said earlier, this is a never-ending story of the latest hotness versus getting your SLAs done, and it's been a balance in IT organizations virtually forever. So it's almost like there's nothing new here, and it plays out in terms of the stability curve for the new applications, and actually this one's interesting, the interoperation issues between Impala and Hive. If you look at these two JIRAs, they're kind of awesome because they show the co-opetition in our industry, where the Impala is, of course, mostly Cloudera folks and there's a bug where queries in Impala can't update the Hive metastore. And of course, there are a lot of companies behind Hive. Hortonworks is one of the main protagonists there. And it was very interesting to read the Hive JIRA, because the Hive folks say, yeah, this is a Cloudera bug, and twist the knife a little bit, but we're going to fix it, right? So it's very interesting to watch the co-opetition play out, and this is kind of the political interaction now between the more batch-oriented and the more interactive systems. And then I went through our support issues with all of our systems, and a lot of these issues come down to setting the yarn container size right and getting the JVM heap configuration right. And if any of you are from Sun, backspace, Oracle, it would be great to have a conversation about where are we at with respect to having to statically set JVM heap configuration and specifically heap size. I would love for a mapper or reducer to be able to say, hey, I know I asked for this much memory, but I'm doing nothing but garbage collection, or even my name node process. I'm doing nothing but garbage collection. All things being equal, operating system, would it be okay with you if I expanded the resources that I'm using? So that would be a fundamental change in Java as far as I know, but it would really help out our customers. I don't know about you and your customers. Okay, so just one last slide. We're big advocates for data scientists and data engineers doing the right, using the right tools for the right job. So we are great fans of Spark and Impala and H2O and a number of the other tools that I've had on the slides. And we believe deeply that those can get combined with the more traditional MapReduce and now TES, but the more traditional Hadoop workloads. The other thing that we believe is, especially data scientists, but really nobody should be spending their time on cluster maintenance. We're infrastructure nerds. We do that. And one thing that's good about what we do is we can see what's happening over all of our customers. And the statistics of that looked a lot like the statistics in this audience, I think, in terms of what kinds of things you're using and where you are in terms of ramp up on the system. So if there's any moral to this whole story, it's, you might want to leave the maintenance to the infrastructure nerds so you can focus on your business use cases. So that's all I've got. I'm happy to answer questions, take comments. Anybody who wants to throw fruit, I'll try to catch it. Going once. Oh, there's a question here. If you could use a microphone, that would be good, or I can repeat.
Yeah, my question was,
yeah.
In your slide you said one size doesn't fit all in one configuration scheme.
Yeah, so the question was, I pointed out in a slide that one size doesn't fit all, but one schema. And when I say configuration schema, I mean we have a template for this is how we set up Hadoop clusters, and that has a number of equations in it. So we take a look at our customers and what kind of workloads do they want to run, what kind of systems do they want to run, and then we've got machinery that says, okay, fill in the blanks, here's what you need. Right, so our clusters have some heterogeneity between our customers. However, there's one templating system that can create those. That's what I meant by that. Okay, looks like we're losing quorum here. Thanks so much for attending. I'm happy to answer questions offline. I'll stick around for a little while.